Hello everyone, I'm Anirudh. I'm a second year undergraduate student studying in the Department of Computer Science in Indian Institute of Technology, Kharagpur. That's in West Bengal, right? So I'm going to be taking exercises from the sets, relations, and functions chapter of class 11 mathematics. This chapter is just a primer of what exactly a set, a relation, and a function is. Right, because you're going to be using relations and functions in the upcoming chapters, especially in your differential calculus and integral calculus, where you're going to entirely be dealing with functions. And to deal with functions, you need to know what a relation is, because functions necessarily are specialized relations, right? And each of these depends entirely on the notion, on the abstract notion of what a mathematical set is, right? So just a brief, a set is going to be a collection of unique objects that are represented mathematically by some symbol way or form, right? It can be a set of operations which may be denoted as the set of like plus, a dot, cross, exponentiation, whatever else you want to add, right? This is going to be a set of operations. Or you can represent a set of numbers, like the set of natural numbers, which is just the set of 1, 2, 3, 4 till infinity, or the set of rational numbers, which is 0.5, 0.75, whatever decimal you want to add, etc., and so on. Right? It's a mathematical construct which denotes a collection of unique objects. And for a set, you can't have two identical objects in it, because that is just, unnecessary. So the set of 1, 1 is the same as set of 1. That's kind of an elementary set idea. A relation, on the other hand, is going to be a pairing, a mapping between two sets of some kind, right? Where you say that some set A and some set B are related through something, through a relation of sorts, R, right? If this kind of a relation, if some relation between A and B exists, that relation is called, that R is going to be termed as a relation, right? And if this relation satisfies some set of properties which I'll be coming to when I'm doing the third exercise here, that relation is going to be defined as a function, right? So having given this primer, let me start with the 4 exercises that we have in store. So exercise 2.1, first question, right? I hope you guys read NCERT, because NCERT is going to be really important. But even if not, I'm going to be explaining each and every step of what I do. So I think that should be fine, but please read NCERT, guys. Question number 1. The pair x by 3 plus 1, y minus 2 by 3 equals the pair 5 by 3, 1 by 3. So the first thing you need to know when dealing with pairs is that this comma separates two fields, right? First, second, first, second. And for equality of any ordered pair, right, the first object has to be equal to this first object, and this second object has to be equal to this second object. Sorry for the stupid selections, right? So basically, out of this pair, I can just, separate this as x by 3 plus 1 equals 5 by 3, and y minus 2 by 3 or 2 by 3 equals 1 by 3, right? So basically, having gotten these two equations, you can just see that this reduces to x by 3 equals 2 by 3. That means x equals 2, right? And y minus 2 by 3 is 1 by 3. That is y equals 1, right? So basically, elementary solving of two equations. And you get the idea that for an ordered pair, the first of the ordered pair has to be equal to the first on the other side, and the second has to be equal to the second on the other side. Right? That solves question number 1. Question number 2 goes as, if set A has 3 elements, set B has also 3 elements, find the number of elements in A cross B. Right? A cross B is a special relation termed the Cartesian product, where you basically make ordered pairs of every element of A and every element of B. Right? A Cartesian product is never commutative. That is, A cross B does not equal B cross A. Right? That the whys and hows of that you will get to know when you read NCERT, because I don't think we have enough time for me to go through that. So we have that set A has 3 elements, set B has 3 elements. The number of elements in the number of elements n of A cross B is basically equal to the number of elements n of A times the number of elements n of B, right? This is, I'll just denote an int. So here, this is basically an elementary property of the Cartesian product relation. This is because for a Cartesian product, you basically pair every element of A with every element of B. And so you have n of A times n of B number of ordered pairs that you generate, right? So basically, this is the formula for n of A cross B. And here you have three elements. So this is basically n of C, where if C is equal to A cross B, then you have n of C equals 3 into 3, that is 9. That solves question number 2. If you want to check, you can just, make A into an arbitrary set of elements A, B, C, where A, small b, small c are variables. And you can generate A cross B as the set of A1. Wait, this is A1, this is A2. Wait, it's not 1, 2, 3. This is A3. This is A4. This is A, 5. Then you have B3. You have B4. You have B5. Wait, where's my mouse not written? And then you have C3. You have C4. And you have C5. Right? You can check that all ordered pairs have been generated. Right? I haven't left anything because you can only have 9 pairs as per the formula. And the generation is basically taking A, B, C and commutating it with making a product with 3, 4, and 5, right? A3, A4, A5, B3, B4, B5, C3, C4, C5. You don't have any other unique pair. And so you can just count that this is 1, this is 2, this is 3, this is 4, 5, 6, 7, 8, 9. And you have 9 numbers, right? That's an elementary proof. Question number 3. If G is 7, 8 and H is 5, 4, 2, find G cross H and H cross G. This is a great way to denote that, to prove that the Cartesian product is not commutative, right? Where for getting GH, you need to pair the elements of G with elements of H, right? So this is basically pairing 7, 5, 7, 8, and 7. Wait, why 8? This is 7, 4, 8, 5, 8, 4, 8, 2. Yeah. So you have G cross H as 7, 5, 7, 4, 7, 2, 8, 5, 8, 4, 8, 2. Right? For G cross H, the elements of G are always first in the pair. The elements of H are always second in the pair. And for H cross G, you have the set of elements 5, 7, 4, 7, 2, 7, and you have 5, 8, 4, 8, and 2, 8. It's very easy to see that 7, 5 is not equal to 5, 7, right? Because drawing a Cartesian plane, drawing the Cartesian plane, you can basically see that if this is 7, this is 5, and this is 5, or this is 8. This 7, this 7, this 5, this 5, 7, 5, 5, 7. I'm not marking anything else, right? 7, 5 lays somewhere here, while 5, 7 lays somewhere here. They are two distinct points. And so these two are two distinct pairs, right? So it's very easy to see that this G cross H does not equal this H cross J because at least one of its elements are not equal, right? So this Cartesian product is not commutative, right? That's some extra bit of information that's not asked for in the question, but I had to explain it. Right? Now going to question number 4. State whether each of the following statements are true or false. Right? So A, if P is Mn and Q is Nm, then P cross Q is M, N, N, N. At first glance, you kind of think that it's true, but it's false, right? It's actually false, right? Because for the Cartesian product, you need to take the product of each element with each element of the other set. So it's basically M, N, M, N, then M, M, and then N, M, and then N, N. The Cartesian product is the Cartesian product of P and Q. It's a set of 4 elements. It's not a set of 2 elements, right? So this basically P cross Q equals this. So 1 is false because you see that here there's only 2 elements. I mean, you can also say this elementary false by using the formula of n of P cross Q, because NP is 2, NQ is 2. So n of P cross Q must be 4, but there are only 2 elements here. That's false, right? 4 is not equal to 2. But there's this a wider method, and this shows you what statement is actually right. For his second part, if A, B are non-empty sets, then A cross B is a non-empty set of ordered pairs X, Y, such that X belongs to A, Y belongs to B. That's true. That's basically the definition given over here. Yeah, that's basically the definition given over here. Cartesian product is a set of all ordered pairs of elements from P and Q, that is P comma Q, such that P belongs to P and Q belongs to Q. So since this is basically the definition, 2 is true. Sorry for my handwriting, that's just stupid. And question number 3 is A12, B34, then A cross B intersection 5 equals 5, right? First property of an elementary set, B cross B intersection 5, B intersection the null set. Any set intersection the null set is a null set, right? I hope everybody knows that. So now, using this property, you see that this is basically the set A taking Cartesian product with an empty set and using this property, right? If either P or Q is a null set, P cross Q will also be a null set, right? So this is basically a null set. Therefore, it is true, right? That solves question number 4. And coming to 5. 5 is A equals the set 1 minus 1, find A cross A. So here it's basically going to be brute forcing, right? A cross A is the set of ordered pairs 1, 1, 1 minus 1, minus 1 minus 1, minus 1 1, and minus 1 minus 1. 4 ordered pairs. This A cross A, right? This itself is a set. Say this is B, right? Now B cross A is going to be the required product A cross A, which is basically this cross 1 comma minus 1, right? Then 1 minus 1, 1, 1 minus 1 minus 1, right? And then minus 1, 1, 1, minus 1, 1, minus 1. Then you have minus 1, minus 1, 1. And the last element, minus 1, minus 1, minus 1. You have this set of 8 elements here. That is A cross A. This whole thing. Right, I'll just show you this at 1, 4. 1, 1, 1, 1, 1, minus 1, 1, minus 1, 1, 1, minus 1, minus 1, minus 1, 1, 1, minus 1, 1, minus 1, minus 1, minus 1, 1, and minus 1, minus 1, minus 1 are the 8 elements in A cross A. Right? Easy to see that there has to be only 8 elements because n of A is 2, and this is basically n of A into n of A into n of A. That's 2 cubed, that is 8. Right? That solves question number 5. Going to question number 6. A cross B is AX, AY, BX, BY. Find A and B. Right? Now you have the fact that A cross B is equal to the given set, right? The given set. So you have that the distinct elements of the first of each pair is going to belong to A, and the distinct element which are the second in each pair is going to belong to B, right? So basically, A is going to have be the set A, B, right? Which is basically the set A comma B, because repetitions don't matter in a set. AB is equal to AB, which is equal to AABB, which is equal to ABBA, is equal to whatever permutation you want to get from A and B, right? It's going to be the same. So the set A is basically A comma B, and the set B, by the same logic, is going to basically be X comma Y, right? And you can basically see that A cross B is going to be AX, AY, BX, BY from here. Easy to take a product from here, right? That's all question number 6. And question number 7 is going to be right. Is going to be a proof, right? So this basically A cross B intersection C equals A cross B intersection A cross C, right? I'll deal with this. I'll deal with the LHS first. Right. You have the fact that B intersection C, right, is basically 1, 2, 3, 4 intersecting 5 and 6. That is 5. That's a null set, right? Because there is no overlap. There's no overlap. So this is going to basically be a null set because anything taking Cartesian product with a null set yields a null set, right? That's the problem. So the LHS is going to be a null set, and we have to deal with the RHS. This A cross B, which is building the roster, that is 1, 1, 1, 2, 1, 3, 1, 4, and 2, 1, and 2, 4. If any of you guys find a faster way to, make a roster of the Cartesian product, feel free to do so because this is just boring. And then getting to A cross C, A cross C is faster. You have 1, 5, that's 1, 6, and then it's 2, 5, and it's 2, 6, right? 4 elements, 1, 5, 1, 6, 2, 5, 2, 6, right? And you can see that there is quite literally zero overlap between the elements of A cross B and the elements of A cross C, right? So you have the fact that the intersection of A cross B and A cross C is going to again be a null set. So you have the simplified equation 5 equals 5, which means that this basically the principle number 1 is verified, right? That's 1 taken care of. And 2, I mean, it's verified for the given values of A, B, C, and D, but yeah. And 2, that A cross C is a subset of B cross D. For that, we need to enumerate A cross C, which is basically done over here, right? I'm not listing it again. It's boring. Right? Just see up, right? And you have that B cross D. Wait, I'm writing B again. B cross D equals, it's basically 1, 5, 1, 6, 1, 7, 1, 8. Then you have the same for 2, 5, 2, 6, 2, 7, 2, 8. And you have the same for 3, 5, 3, 6, 3, 7, 3, 8. And you have the same for 4, just 4, 5, 4, 6, 4, 7, 4, 8. It's going to be much faster if I can dictate it somehow to the code. So you have the 16 elements over here. That's B cross D, right? Because B is 1, 2, 3, 4, D is 5, 6, 7, 8. Right? And you have the fact that A cross C is basically 1, 5, 1, 6, 2, 5, 2, 6, which is 1, 5, 1, 6, 2, 5, 2, 6 over here. Let's use a highlighter. 1, 5, 1, 6, 2, 5, 2, 6. These 4 elements. These are A cross C, and the rest is B cross D. Right? It's easy to see that A cross C just belongs to B cross D. Right? It's easy to see that this property holds true. So basically, A cross C is a subset of B cross D because 4 elements, which is A cross C, lies in B cross D. Right? So basically, you have this 2 also verified. 2 is verified. And so you have finished the 6th question successfully. And the 7th, right? Going to the 8th question, right? Let A equals 1, 2, B equals 3, 4, write A cross B. Again, it's really a boring working. A is 1, B is 3, then you have 1, 4, then you have 2, 3, and the pen is not writing. I don't know what's the problem with this. You have 2, 4, right? 4 elements of A cross B that you get the Cartesian product. So you have this. How many subsets will A cross B have? I hope you guys remember that this question is basically asking for the number of elements in the power set of A cross B, right? I hope you guys remember this. And the formula for this is basically 2 to the power of the number of elements The formula for this is basically 2 power number of elements in A cross B. That is, right, that's 2 to the power of 4, that's 2 power 4, that's 16. Okay, that's the problem of the whiteboard. So basically, you're going to have 16 subsets of A cross B, which you can check, right? The first subset is going to be the null set 5. Everybody knows that. And there are going to be 4 subsets with 1 element. That's 1, 3. That's a set of 1, 4. There's a set of 2, 3, and there's a set of 2, 4. Right? 4 elements with a 4 subsets which are going to have 1 element. Right? I'm going to denote subset of 1 element within brackets like this. Right? That's this 1, this 4, and then you're going to have 4C2 elements, 4C2 subsets of 2 elements. Basically 1, 3, 1, 4, 1, 3, 2, 3, 1, 3, 2, 4. That's 3. And then 1, 4, 2, 3, 1, 4, 2, 4 makes 5. And then 2, 3, 2, 4 makes 6. Right? That's 4C2. That's basically 6. 6 elements, 6 2 element subsets. 4 3 element subsets again. 4 3 element subsets again. And you have 1 into the full set A cross B. Right? Because the set itself is a subset. Right? So basically you have 1 plus 4 plus 6 plus 4 plus 1. If anybody wants to deal with that, that's going to yield 16 again. Right? It's an elementary combinatorial formula. That's NC0 plus NC1 plus NC2 plus NC3 plus dot 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 till NCN. That is sigma over I NCI. Basically gives you 2 power n. That's a combinatorial formula. If anybody wants to remember that, you can. Or else you're going to anyway deal with it in NCERT, so not an issue. So that deals with, wait, no. And you have to list the subsets of A plus B. Damn, one make my life harder. Right. So the power set of A cross B, the power set of A cross B is basically going to be the set of sets, the set of null set, that's 5. The set of all singletons, that's, I'll just make this A, this B, this C, this D. Don't get confused between A, B, C, and D, because A is 1, 3, B is 1, 4, C is 2, 3, D is 2, 4. Right? I don't want to keep writing the whole pairs again and again. That's just waste of my time, waste of your time. Right? So this is going to be the set of A. Anyway, my pen is always metal. Right? The set of A, the set of B, the set of C, the set of D, set of D, and then the set of AB, 2 element subsets. You have the set of AC, then it's not writing again. You have the set of AD, and then you have the subset BC. You have the subset BD. You have the subset CD. Right? Wow. Still have 5 to write. You have ABC. In the same way, you have ABD, and you have ACD, and then you have BCD, which marks the end of the 3 element subsets. And finally, you have everything that's basically ABC. Right? That's the end of the power set of A cross B. And you can basically count the number of elements in it, which is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, and 16. Right? You have 16 elements, that's 2 power 4. That's the number of elements in power set of A cross B. Right? And then you have the second last question, number 9, which basically asks you to find A and B. Right? Again, as we did in this question 6, right? This basically the distinct elements of the first of each pair, the distinct elements of second of each pair, that's A and B, right? So basically A is X, Y, Z. Since they have given that X, Y, Z are distinct, that means that set A is basically fulfilled because you have enough A's 3. 1, 2, 3, that makes 3 elements. A is X, Y, Z, finished, right? You don't even need to think anymore on this. You just have it. Right? And you have the set of B is basically 1, 2, and 1, right? which is equal to set of 1 and 2, right? Because repetition does not matter in a set, right? And the number of elements in 1, 2 is 2. So you have n of these two there, finished. So basically you have A is this set X, Y, Z, B is a set 1, 2. And there you go. That finishes question number 9. And you have the last question. Cartesian product AA has 9 elements, among which are found -1, 0 and 0, 1. Find set A remaining elements of A cross A, right? Either find set A because you have, it's basically in the vein of question number 9 and question number 6, where you have the set A equals the elements -1, 0. It's actually not equals, but it's basically a superset, right? The set A contains these elements, right? -1, 0. And it also contains the elements 0 and 1, right? So basically you see that you have A cross A has 9 elements, which means that NA squared is 9, which means that N of A equals 3, right? Because you can't get 9 elements any other way, and the number of elements cannot be negative. And that makes no sense. So basically you have N of A is 3, A has -1, 0, and A has 0, 1. So from this you can basically construct that A is equal to -1, 0, right? You can say that -1, 0 belongs to A, 0, 1 belongs to A. Done, right? And N of A is 3. You have 3 elements. So A cross A is basically, right? A cross A is going to be the set of -1, -1, -1, 0, -1, 1, 0, -1, 0, 0, 0, 1, brackets, and 1, -1, 1, 0, and 1, 1, right? That makes A cross A. And removing these two elements, that's -1, 0 and 0, 1, you have the rest of the elements of A cross A. Done, right? This is A cross A. That finishes exercise number 2.1. Exercise number 2.2's preview is basically a relation, where you have the definition that a relation is a subset of the Cartesian product A cross B, which describes a relationship between the first and the second element of the ordered pairs in A cross B, right? You have this extra thing. The second element is called the image for each relation R, right? And the set of all first elements is basically the domain of the relation R, right? The set B, on the other hand, is called the codomain, right? The codomain as such does not really matter. Is the whole set B which need not be used in a function, which need not be used in a relation. They're not dealing with functions, right? But this codomain is a necessary term which I'll see later. You have two elements, two ways to denote a relation. That's basically by the roster or the set builder method, and it's visually represented by an arrow diagram, right? This is an arrow diagram. And you have the fact that the total number of relations is basically 2 per PQ. If N of A is P, N of P is Q. Because each relation is a subset of the Cartesian product, and there are 2 per PQ subsets of the Cartesian product itself. That's basically why the number of relations is 2 per. And without further ado, let's go to exercise 2.2. Right, question number 1. Define relation where 3x minus y is 0. Write down its domain, codomain, and range. Right. So basically here you have the fact that 3x equals 5, and you have the constraint that y belongs to this set A. You have the constraint that x belongs to this set A, right? These two constraints are simultaneous because the relation R goes from A to A, right? The domain, the superset of the domain is also A. The codomain is also A, right? So basically, you can say at the start that the codomain is basically equal to A. Done. Finished. Because the codomain is basically the second set to which the relation travels to, right? It's not from, it's to, right? This is the codomain. And so you have the fact that this can basically take values of 1 to ... 14, and this can also take the same values. So basically, this is a whole number. This is also a whole number, right? If this is a whole number, then y can only be multiples of 3, which is less than 14, because Set A only travels up to 14. So basically, Y takes the values 3, 6, 9, and 12, right? And so X takes the values 1, 2, 3, and 4, right? You can see that if X takes the value 5, then Y should be 15, but 15 does not belong in A, so Y cannot be 15, right? So X cannot be 5. Same goes for 6, 7, 8, 9, 10, 11, 12, 13, 14. So basically, this set is the domain, right? This set 1, 2, 3, 4 is the domain. And this set 3, 6, 9, 12 acts as the range. The codomain is entirety of A. So you have domain is this, range is this, codomain is this, you have all three. You have finished first with the first question. Going to the second, right? I'll let you. Define a relation R of the set of n of natural numbers, blah, blah, blah. Depict this relationship using roster form, write down domain. So you are given a set builder relation. That's Y equals X plus 5 and XY belong to N. XY belong to N, right? The set of natural numbers N, right? So you have the fact that X is less than 4, right? So basically, X belongs to the set 1, 2, because there are only 3 natural numbers, which is less than 4, right? Basically, this statement and this statement give rise to this statement, right? If X is 1, 2, 3, then Y is basically 1 plus 5, that is 6, 2 plus 5, that is 7, 3 plus 5, that is 8. Only 3 numbers, because you only have 3 numbers in the domain. You can have at max 3 numbers in the range, right? So you depict this relationship using roster form. That is set R equals the set of 1, 6, the set of the pair of 2, 7 is not a set, and the pair of 3, 8. Right. So this deals with the roster form of relation R. You have this to be the domain, the set, and you have the range to be the set. Right? Domain is basically 1, 2, 3. Range is basically 6, 7, 8. Finished. Right? That deals with question number 2. Question number 3 is A is 1, 2, 3, 5, B is 4, 6, 9. Define a relationship where R is X, Y says that difference between X and Y is R. Right? Right, R and roster. So here we are basically given that the difference between X and Y, that is the absolute difference mod X minus Y, is odd. So this basically means that X and Y are of different parities, right? Where parity is basically the oddness or the evenness of each number. If X is odd, then Y has to be even, and vice versa. So if this is odd, this is even, then the difference will be odd. The same way, if this is even and this is odd, the same thing happens. The difference is basically odd, right? If it's odd, or even, then the difference is even. So the odd, even pairs should not come. X is odd, Y is even, or X is even, Y is odd. Basically, that X and Y are of different parities, right? So you have this fact, and I'm going to build R using the same fact, right? I'm not going to check individually each and every difference, because I can just generalize it using this principle, and this is going to be true, right? Because I know it to be true, right? And you can also check it to be true. That's not an issue. So basically, you have 1, 4. That's 1, 4. It's an odd even pair, right? You have 1, 6, right? This deals with one's images, right? 1, 9 will not come because that's an ordered pair, right? To check 1, 4, the difference between 1, 4 is 3, the difference between 1, 6 is 5, both are odd. And then you have the pair 2 and 9. Because 2 is even. You can only have an even odd pair. That's 9. And the difference between 2 and 9 is 7. Easy to see. If you take an even pair, that's 2, 4 or 2, 6. You can see that's basically 2, 4 is 2, that's even. And 2, 6 is 4, that's also even. Right? They won't come. And then you have 3, 4. You have 3, 6 as pairs. And then you have 5, 4. and 5, 6 as pairs, right? That deals with the roster form of R, right? You only have 7 elements. You don't have any other. You can also check, right? Because the other elements, that's 1, 9. The difference between 1 and 9 is 8, even. You have 2, 4, 2, 6. I've already explained, that's even. You have 3, 9, that's again even. And you have 5, 9, that's again even, right? 3, 9 and 6. 5, 9 difference is 4. Both are even, right? That deals with the roster form of set R. So your question number 3 is done. Question number 4. The figure 2.7 shows a relationship between P and Q, rises in set builder and roster form, right? The arrow diagram is basically between 5, 3, 6, 4, and 7, 5. You can see that this is basically the element in P minus 2 equals the element in Q, right? Because 5 minus 2 is 3, 6 minus 2 is 4, 7 minus 2 is 5. So if X belongs to P and Y belongs to Q, you have the relation R equals the set of X and Y such that X minus 2 equals Y. That this is basically the mathematical form of this expression that I've written. So your relation R in proper set builder notation is basically the set of X comma Y such that, or this line, I prefer the line because that's easy to draw, right? Such that X minus 2 equals Y, comma, X belongs to P, Y, I don't know what's happening here, right? Y belongs to Q. That is the set builder form, the SB form of set R. And your roster form is basically, R equals set of 5, 3, 6, 4, and 7, 5. Done? 3, 5, 3, 6, 4, 7, 5, 3 arrows, 3 elements. Set R equals this. Done? That's set builder plus a form, right? Domain and range. The domain is basically every element in set P, and the range is basically every element in set Q, right? Domain is equal to P. Range, why is it not writing? Range is basically set P. Because you can see that every element in P has an element in every element, has an image in every element in Q. So I can directly write that domain is P and range is Q, right? Or you can also expand it from this roster form and say that the domain is basically every first element, that's 5, 6, 7, right? And the range is every second element, that's 3, 4, and 5. So that's 4. And then you have question number 5, that's 1, 2, 3, 4, 5, 1, 2, 3, 4, 6, right? Let R be relation defined by B is exactly divisible by A, and each pair is A and B. So you have the fact that the relation is on A, that means the relation is from A to A, right? R is from A to A. This basically means that the superset of the domain is A and the codomain is also A, right? So you have that B is divisible by A, which means that I can directly go ahead and write R in roster form as 1, 1, right? Because every element is divisible by itself. So 1, 1 exists, 1, 2 exists, because 2 is divisible by A, 2 is divisible by 1, and then you have 1, 3, you have 1, 4, and you have 1, 6, right? This you have 5 elements here, and then you have 2, 2, you have 2, 4, you have 2, 6, right? And then you have 3, 3, you have 3, 6, and then you have 4, 4, and then you have 6, 6. Because 6 is not divisible by 4, you don't have 4, 6, and so on and so forth, right? So you have 5, 5, and 2, that's 12 elements in R, right? The domain D of R is basically equal to the set of all first elements, that's 1, you have 2, you have 3, you have 4, you have 6, right? And the range is a set of all second elements. That's also 1, 2, 3, 4, right? So this is basically equal to A. This is also basically equal to A, right? So I've finished question number 5. And question number 6. Question number 6 is determine the domain and range of relation R defined by x plus 5, x belongs to 0, 1, 2, 3, 4, 5. Right? Here, be very careful. You're given that x belongs to this, but you're not given that R is from anything to anything. So you can basically assume that R is a relation from the set of real numbers, right, to the set of real numbers, right? You can basically assume this. That's not a problem, but you should not assume that it's something that's a subset of real numbers, because then there may be the chance that your range does not include the whole thing, right? Every element in the range may not come into whatever you assume. So you have to be very careful in this, right? So you can assume that R is from real to real, and you have the fact that R is basically the set of x comma x plus 5, where x belongs to 0, 1, 2, 3, 4, 5. Given inside builder, I'm going to transform this into a roster form. So basically you have 0, 5, right? 0 and 0 plus 5. You have this set 1, 6. You have this set 2, 7. You have pair 3, 8. You have the pair 4, 9. And you have the pair 5, 10. 6 elements. And so you have that domain is equal to 0, 1, 2, 3, 4, 5. And you have the fact that range is basically range is 5, 6, 7, 8, 9, right? 6 numbers. And your question number 6 is done. You have found the range, you have found the domain, and you have the relation R equals x plus 5, where x belongs to this. Basically, I gotta say that the domain is of basically 0, 1, 2, 3, 4, 5 from here, but writing the set builder form is writing the roster form is basically going to be more illustrative of what the domain and the range is. Right? Question number 7. Write the relation R x comma x cube x is prime number less than 10 in roster form. Right. So this condition you have to first evaluate. Right. X is a prime number less than 10. So x basically belongs to the set of 2, 3, 5, and 7. Only 4 numbers, because the next prime number is 11, which is greater than 10. Right? 9 is not a prime number, 8 not, 6 is not a prime number, 4 is not a prime number, 1 is also not a prime number. 1 is unique. The roster R equals, this is 2 and 8, 2 cube is 8. You have 3 and you have 27. You have 4. You have 64. And you have, why did 4 come? You have 5 and 125. And you have 7, 343. Right? These are the 4 elements that are going to be in x comma x cube, where x is a prime number less than 10. Right? That's your roster. Question number 8. Too much. Number 8. X is x y z, b is 1, 2. Number of relations from A to B. Basically, this formula 2 par PQ, and this is n of power set of A cross B, right? Because that's what is the number of relations from A to B, is equal to, this is 2 to the power 3 into 2, right? Because n of A is 3, n of B is 2. So this is basically 2 power 3 into 2, that's 2 power 6, that is, right? Therefore, you have 64 relations from A to B. And the last question, that's question number 9, that gives you the relations A comma B, where A minus B is an integer. Find the domain and range of R. Right. You have the relation is on Z. That means the relation is on the set of integers. That's the negative numbers and positive numbers and 0. A minus B, you should know the closure property of integers. That is, A minus B is also an integer if A and B are also integers, right? Because for any two, any two negative numbers, -1, -3 is there. -1 minus 3 is 2, this is an integer, right? And the reverse, -3 -1, -1 minus 3 is 2, which belongs to Z, right? And -3 -1 is equal to -2, which is also an integer, right? And I'm just using the double line to differentiate between an actual Z and the set Z of integers. And the same way to take for in 1 and 3, 1 minus 3 is basically this, and 3 minus 1 is basically this, right? So you can see that whatever be your choice of numbers, you have a difference that also belongs to integers. So basically, a minus b is an integer, means that for every a and b which belongs to Z, this holds true, right? So this relation R is basically the Cartesian product of the set of integers on itself. All right, it is basically Z cross Z. That is R. So the domain D is equal to the set of integers Z, and the range R is also equal to the set Z of integers. Range is also the set of integers, right? Because every integer can be mapped to every other integer in this relation that a minus b is an integer, because integers are closed under subtraction, right? That takes care of exercise number 2.2. And going to 2.3, we have a primer on functions, a special level relation. Right? I don't know that I'll say what the speciality is, right? And here you have definition 5, that a relation from set A to set B is said to be a function if every element in A has one and only one image in set B, has a unique image in set B, right? So you have the fact that if AB belongs to F, then F of A equals B, and F of A does not equal some other number C, some other element C that belongs to B, right? B is called the image of A under F, A is called the pre-image of B under F, right? These are special terms which you should not forget because they'll be used elsewhere also, right? Function is denoted by F from A to B as you denote a relation, because a function is a specialized relation. That is basically the only speciality of a function. And you have this, that a function which has either a real or one of its subsets as its range is called a real valued function, right? A real valued function is basically going to have a range that belongs to the set of real numbers, right? These are some special functions and their graphs. That's identity function A, that is f of x equals x, right? Y equals f of x equals x, right? That is this function. Straight line traveling at 45 degrees to the x, 45 degrees to the y axis, right? A constant function, that is y equals f of x equals c, that's a straight line parallel to the x axis. And a function x equals, a function or an equation which has no y component cannot be a function, right? Basically saying that this line perpendicular to the y axis, defining a relation on that line, right? And defining on the relations of R equals the set of, right? That's not right. The set of x comma y such that x always equals 3, right? X always equals 3 does not generate a function, but it generates a relation. It generates just a relation, right? Because for a function to exist, your x comma y is not writing. So you basically have the fact that, so here you have the fact that for every, for every first element 3, you have an infinite number of second elements y, right? So which basically violates this condition that you can only have one and only one image in set B. Here you have an infinite number of images in set B. So this is not a function, but this is a relation, right? This is an extra fact, don't mind me, right? And you have a polynomial function, that is y equals f of x equals a0 plus a1x plus a2x squared, blah, 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 blah. See this in the inside a book. This is basically, a polynomial relation that y equals a polynomial, gives a polynomial function. Y equals y equals x square is a parabolic function. y equals x cube comes like this, right? And then you have y the greater functions which are basically going to be extensions of y equals x squared next, right? Rational functions of the fire type f of x by g of x, right, are special in the sense that g of x can never be equal to 0, right? This is a hyperbolic function f of x equals 1 by x, and you can see that it is not defined at x equals 0, right? At x equals 0, the function either tends to infinity or it tends to minus infinity as you approach from the negative or the positive side, right? It does not, the value of the function at 0 does not exist, right? And the modulus function, a special type of function which is V-shaped, right? So it is basically split as x, x when x is greater than or equal to 0, right? This line, or it's minus x when x is less than 0, this line, right? The signum function or the sign function, which basically denotes the sign of the sign of any variable, right? The sign of the value. If x is greater than 0, it is 1. If x is 0, it is 0. And if x is less than 1, it is minus 1. Right? F of x is 1 if greater than 0, 0 equal to 0, minus 1 if less than 0. You have GIF, which is basically the step function, which is a series of steps, right, here, which basically denotes the greatest integer less than or equal to any integer, any value, real value x. So from minus 3 to minus 2, your GIF of x is minus 3. From minus 2 to minus 1, when minus 1 is not included, your GIF is minus 2. This circle basically denotes that this value is not included. So if x is minus 2, then GIF of x is minus 2 and not minus 3. But the value right next to minus 2, that is minus 2.000000001, something that's infinitesimally less than minus 2, that gives you minus 3. That's why you need this hole here, which basically says that minus 2 is not included, right? Property of the graph. And then algebra, and then you have examples, etc. Possibly. So going to exercise number 2.3, I'll just reload this whiteboard once, right? And so you have exercise number.
अनिरुद्ध एक मिनट
Yes, sir.
मुझे टाइम दे दो. मैं ये कह रहा था कि ये एक्सरसाइज 2.3 के बाद या जब भी तुम्हारा फिनिश हो जाए तुम क्लोज कर देना मीटिंग को, बिकॉज मुझे
Yes, sir.
कुछ
Sure.
काम है. मैं
Sure.
बता रहा हूँ.
Sure,
एक अनिरुद्ध, you have a session on Saturday at 2 p.m. You have a session on YouTube live.
Yes, sir. That's at 2 p.m.
2 p.m.
Right, sir.
So
Right, sir.
please be on the time. और
Yes, sir. Yes, sir.
है ना 2 p.m. पे start करेंगे, live है YouTube.
Yes, sir.
So
Sure.
all the very best and thank you so much. Your teaching methodology is too good, Anirudh. You are teaching very, very, very nicely. So thank you so much.
Thank you so much. Thank you so much.
And great. So मैं थोड़ा सा जा रहा हूँ, बाकी जब तुम ओवर हो जाए तो मीटिंग लीव कर देना, राइट?
ठीक है सर, ठीक है.
Okay, thank you.
Thank you so much, sir. Continuing in 5, 4, 3, 2, 1. Right. Exercise 2.3. Right. Okay, we're going to see my whiteboard, right, properly. Question number 1. Which of these relations is a function? You are basically asked to, apply the properties of functions again and again and again, so that it just gets cemented into your minds, right? If it's a function, determinants, dominant range, right? The first subpart, that's 2, 1, 5, 1, 8, 1, 11, 1, 14, 1, 17, 1, right? I'm not writing this again, right? I'm basically denoting this as R1. Why is it not writing again? Right? This is R1. So your R1 is basically each element of the domain being mapped to the same element. That's 1, right? So since 1 has a pre-image 2 or 5 or 8 or 11 or 14 or 17, but the pre-images have only one image, right? Your domain, if your pre-ter existing domain, right? You can't say this a domain because you haven't proved it's a function yet, right? Your set D is basically the set of all first elements. That's 2, 5, why is it 2, 5, 8, 11, 14 and 17, right? That's P, that's D, I'm sorry. And you have the set R equals 1, right? You can see that each element in this D has only one element in R, that's 1, right? 2, 1, 5, 1, 8, 1, 11, 1, 14, 17. And for a function, you need that each element in this set D, the set of first elements, should have a unique element in the set R. That's a set of second elements. Since you only have one element for each, for each element in D, this first thing, this is a function, right? Excuse my whiteboard. There is some problem with it this time. But R1, this relation is a function, right? Many people get confused here, right? Between the many oneness of the domain and the many oneness of the range, right? So there is a very good mnemonic, right? If you have a function from A to B, say, right? From A to B, right? And A consists of some set of elements here. B consists of some set of elements here, right? I'm not really worried about what elements and why, where, when, how. I'm not worried about that, right? So if these are two sets A and B, and your function goes from A to B, right? Your function f, then in your arrow diagram, you cannot have something, you can always have something like this, right? A greater than is always allowed, right? And equal to is always allowed, right? And equal to means that there are two different elements being connected to two different elements, and unequal to is always allowed. But I'll just extend this, right? But a less than relation is not allowed, right? You cannot have a less than. So basically, if this is element C, say, right? C cannot be connected to two different elements, D and E. This is not possible for a function. Otherwise, say this is X, Y, this is X, right? This is X, this is Y, and this is Z. Right? This kind of relation is possible. XZ, YZ can exist in a function, but CA and CB cannot exist in a function, right? This is basically a mnemonic to determine what is a function and what is not a function. I'm not going to erase this. If you want to see, you can see this, right? So this basically is an extra thing. Why is my whiteboard doing such? Going to part number 2, where you have R2. R2 is 2, 1, 4, 2, 6, 3, 8, 4, 10, 5, 12, 6, 14, 7. Each is a unique element in these. I'll just separate the set D and the set R first, right? The set D is 2, 4, 6, 8, 10, 12, and 14, right? 12, 12, 12, 12, 12, 12, 12, 12, yeah, 12 and 14, right? And the set R is basically 1, 2, 3, 4, 5, 6, 7. I'm not writing everything down, right? It's 1, 2, dot, 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 7. I'm not a patient guy. Sorry to say, right? So you have the set, the domain as 2, 4, 6, 8, 10, 12, 14. The range as 1, 2, 3, 4, 5, 6, 7. You have the relation that's X equals 2Y, where the pairs are X comma Y. Right? That's the relation here. And you can see that each element in the domain has a unique element in range, right? So this is a function, right? Down below, right? So this is a function, right? R2 is a function. On the domain D, I have to write that it's on this domain exactly, right? I don't have any more patience. So, like, for a function, if your domain has any extra elements, say if 16 was also an element in D, it's not, but hypothetically, if 16 is an element of D, right? Then if 16 does not have an element in the range, it means that this relation is not a function. For a function, the entire set A should be the domain, right? If a function is defined from A to B, say, if the function is defined from A to B, then the entire set A should be the domain. And the codomain does not really matter, but the entire set A should be the domain. And each element of the domain has to have only one image, right? The image need not be unique in the sense that it need not be how to say this. It need not be a different element in B for every different element in A. But there has to exist some element in B that is mapped to A, that is mapped to every element in A, right? So if this 16 was a part of D, then but there is no corresponding element in R, then R2 will not be a function. Otherwise, if the 16 is not a part of the domain, then this is a function. So we have to specify that it's a function on the domain D, right? Because if you don't specify this, then it means that it's a function on the real numbers. And since you only have mappings from 2 to 14 and not for any other real number, it does not become a function, right? The same way above, here also I have to write that it's a function on the set D. I mean, here I'm using on colloquially. This is not mathematical, right? A mathematical on means that the relation is from D to D. There is a difference, right? This is colloquial. This is colloquial. This is not formal. I'm saying this again, right? Then you have the third subpart. That's R3, right? R3. You basically have the domain D to be 1, and you have your set R to be 3 and 5, right? But this one maps to both 3 and 5. I told you before that in the arrow diagram, you have 1 and you have 3, 5. This becomes a less than relation, right? Because it looks like a less than. It looks like the less than symbol. This cannot be allowed if it's a function. But this happens. So R3 is not a function. It's not a function. That takes care of question number 1. And question number 2. Find the domain and range of the following real functions. Fx is minus mod x, fx is root of 9 minus x squared. I give you two ways to solve each of the following questions. Right? Each of these are 2 questions. Right? The method 1 is basically a normal method where you find the domain and range by looking at the function themselves and then condensing it, etc., etc. The second method will be a graphical one. Right? A graphical one is always easy, but you need to know how to graph it. Right? So I'm going to show you how to graph it also. Right? The first part is basically fx being minus mod x. Right? So, and you all should know that mod x is basically minus fx. If I take a -1 minus fx, the scalar multiplication of -1 and fx, I'm going to get mod x, which is basically x and minus x, depending on if x is greater than or equal to 0 or if x is less than 0. This is minus fx. So fx is going to be x if x is less than 0 and minus x if x is greater than or equal to 0. You have that being f of x. So the domain T of f of x is going to be the set of all real numbers R, and the range R is going to be every number that is less than or equal to 0. Because for x is equal to 0, you have this being -0, which is 0, right? But for any other x, you're going to have some negative value, right? And for -infinity, you're going to have -infinity. So the range is basically -infinity, 0 in closed brackets, right? I hope everybody knows the bracket system, right? If you don't, it's basically that the open bracket signifies and it does not equal to this value, while a closed bracket signifies that this is equal to this value. So basically, this bracket opens up to -infinity less than x less than equal to 0, right? Less than x or less than y, whatever you prefer. All right. This is what this bracket system opens up to, right? Now you have defined the domain and the range for this mod x, right? I'm going to show you how to graph it also, right? First of all, you know the graph of mod x, that is like this. This is mod x, right? This is for mod x. But we have to show the graph for minus mod x, right? Minus mod x is basically going to be the reflection of mod x about the x-axis, because that's what a minus sign signifies. So your minus mod x is going to be this line, this line, and this line, right? This is going to be minus mod x, right? This is x up until 0, x if x is less than 0. And this is minus x if x is greater than or equal to 0. And it touches at 0. So this is basically minus mod x, and this is the function minus the function f of x split as two different lines, right? That's basically, these two are equivalent, right? You can see that it's the function minus mod x is defined for every x here. So the domain is basically the points on the x-axis where the function is defined. That is the real number line r, while the range is the points on the y-axis which are covered, which is the set from 0 till whatever x is downwards, which is minus infinity. So the range is minus infinity to 0. That's right. That's how you graph the function. That's how you get the domain and the range from the graph. And coming to question number 2, where you have fx equals y equals square root of 9 minus x squared, right? I hope everybody knows that the root is always positive, right? So saying this, root 9 is always equal to 3 and it's not equal to plus minus 3, right? Plus minus root 9 is what gives you plus minus 3, right? Do not forget this. This always holds true. Root 9 is not equal to plus minus 3. Now, this being the function, it's easy to see that for something under root to be real, right? We can safely assume that y belongs to real and x belongs to real, right? You can safely assume this. So, because why you can safely assume is because you have a real function, right? So y belongs to r. That means that whatever is under this root has to be greater than or equal to 0. So the first condition you have is that 9 minus x squared is greater than or equal to 0. So basically x squared is less than or equal to 9. And so x lies between minus 3. First condition. You have x belong to minus 3. Right? And so you have the fact that, right, from this, you can see that x squared basically lies between 0 and 9, right? Because minus 3 squared is 9, minus 2 squared is 4, minus 1 squared is 1, and you have every number between minus 3 and minus 1. And then 0 squared is 0, right? 0 is the minimum, 9 is the maximum. And you have this bound for x squared, right? And so for y, right, it's not for y. I'll first say for y squared, right? For y squared, this is equal to 9 minus x squared. You basically have the bounds. Again, it's 9 minus something that lies between 0 and 9. So it basically lies between 0 and 9 again. But y itself is a positive root of 9 minus x squared. So basically, y has to be positive, right? It's not an equal to, right? Y has to be positive, right? Because it's a positive root. Y has to be positive. And y is less than or equal to 3. Because y square can only go up to 9. So y has to be less than or equal to 3. So basically, you have the fact that y belongs to, again, it's a closed 0, comma, closed 3, right? Y is greater than or equal to 0. Y close 0 to close 3. Y belongs to close 0, close 3, right? This is your domain T, Venus force of, right? And this is your range R, right? That solves this question. To do it graphically, right, you need to know that, first of all, x squared plus y squared, right? X squared plus y squared equals c. This equation determines a circle, right? Because this is basically, I'll just write c squared. It is easier and this is going to be the standard form of a circle that we're going to study in coding sections. Right? This basically means that the distance from 0, 0 of any point x, y is going to be constant. Right? That basically determines the circle because the circle has constant radius. Right? So x square plus y square equals c square is going to be a circle. And you have here, it's y squared equals 9 minus x squared, which basically is rewritten to x squared plus y square equals 9. Right? And here, since you have this a positive root, right? That means that you are going to take the positive half of the circle only, which means that you are basically, this equation basically is a semicircle, right? I'm sorry for the not to scale drawing, but I can't really do better because I'm not patient A, and B, I'm not really used to computer drawing, right? Even on paper, my drawing is shit. So yeah. This is 3. This is 3. This is -3. Right? This is a semicircle that is basically determined by y equals root over 9 minus x squared. Right? This part. Right? From here, you can see that the domain is basically every point on x that's covered. That's -3 to 3 over here. And the range is every point on y that's covered. That's basically the 0 to this 3. Right? 0 to 3. Done. That graphing is really simple, but you need to know how to graph to actually get the answers properly. That takes care of question number 2. Then coming to question number 3. A function f is defined by f of x is 2x minus 5 rather than the values of f0. Right? F0 is basically substitute 0 in place of x. That's 2 into 0 minus 5, that is -5. Right? I don't think you need calculations, because if you need calculations, you are far worse off than f0. Right? F0 is -5, right? Equal to. Why is this doing so much problems today? It's equal to -5, right? And then number 2, you have f of 7, right? F7 is basically 2 into 7, that's 14 minus 5, that is 9. And you have the third subpart, that's f of -3 equals, this is -6 minus 5. Yeah, what the hell? -6 minus, that is -11. Right? That takes care of the 3 subparts here. Right? What? So you have f of -3 is -11, f of 7 is 9, f of 0 is -5. 3 is done. Going to question number 4. The function T, which maps temperature in degrees Celsius and temperature in degree Fahrenheit, is defined by Tc is 9c by 5 plus 32. Elementary relation, right? And you are asked to find out the values of T0, T28, T minus 10, and the inverse of 2 and 2. Right? So first of all, you are given, right? And then, yeah, right. So you are given, it's first is T0, which is, just substituting 0 in place of C, that is 32, right? T0 is 32. Then you have T of 28, which is 9 by 5 into 28 plus 32, which is basically, I'm not moved to actually do the calculation, so I'm just directly using a calculator. But if you have to do it, it's just cut 5 this here, it's 5.6 times, and do 5.6 and a 9.4, because 5 nines are 45, 6 nines are 54, and you are going to have a point here, so it's 5.4. It's 45 plus 5.4, that's 50.4 plus 32. Man, let us speak. What can I do? This is basically round. This is basically 82 point, right? That's done. That's T of 28. And then you have the third subpart that asks for T minus 10. That's easier to do because 5 goes to minus 10 2 times, right? It's 9.15. Wow. 9 by 5 into minus 10. That is, here it's 2. It's a minus, so this is minus 18 plus 32. Here you have a plus 32, right? This is equal to minus 18 plus 32. That is right. So t minus 10 is 14. This is t 28 is 82.4. T0 is 32. And then you have question number 4, that is the inverse value of 2, right? Here you have to note that this inverse, this value of C when TC is 212, right? This exists properly because this is a one-to-one function, right? For every value of C, you will have a unique value that is in the range, right? You don't have two values of the range. You don't have a greater than relation. You don't have a great, where is that drawing? Basically, you don't have this kind of a greater than relation over here, right? If this greater than relation exists, then this value need not exist uniquely, right? There may be 2, 3 values of this C for C, TC equals to 12, right? And then you have, then you need some more information to actually pinpoint what value of C they're asking. Okay. But here this is a one-to-one relation, one-to-one function. So there's no need for all that nonsense. You can just directly go ahead. You can substitute 212 in place of TC and then find out C, right? So basically you have that 212 equals 9C by 5 plus 32, which means that 9C by 5 equals 180, which means that C is equal to 20 into 5, that is 100, right? So value of C is 100. I don't have any other value because the equation yields only one, right? That finishes question number 4, and then coming to question number 5. Find the range of each of the following functions: 2 minus 3x, x squared plus 2, and x. Right. So question number 1. You have the constraints that x is a real number, x is greater than 0. So x is not 0, right? So f of x, which is 2 minus 3x, right, cannot be equal to, right? Because this is linear, which means that it is one-to-one, right? You can, again, I'm going to show you 2 methods to do each of these functions. So I'll not graph first, but yeah. And I should not write it's not equal to 2 at the start because then. So this is 2 minus 3x, right? First of all, 3x is always greater than 0 because x is real and x is greater than 0, right? So 3 times x is also greater than 0, right? It cannot be equal to 0, never, right? And so 2 minus 3x is basically less than, wait, I'll not write 2 minus 3x first. I'll go step by step, right? So this is a minus, right? If you multiply a minus to an inequality, the inequality flips. So if 3x is greater than 0, then minus 3x is less than 0, right? Adding 2 on each side, it is 2 minus 3x is less than. So basically, the range of f of x is equal to minus infinity. That 2 minus 3x is less than 2 because this minus 3x is less than 0, adding 2 on either side. So you have this, right? So this means that your range is equal to minus infinity, right? Open, because it cannot be equal to 2 because x is not equal to 0. Graphing this function is very easy. You can see that x is basic, f of x y equals x is basically this, right? Extending on either side, right? Ignore these squiggles, right? This basically f of x equals x, y equals x, right? Y equals 3x is somewhere over here at a slope of 3, right? This is y equals 3x, and then y equals 2 plus 3x comes somewhere over here, right? Where this is basically 2. This is y equals 2, wait, some mistake somewhere, right? So this is x and y. You have y equals, the function is 2 minus 3x, right? Yeah. So it's basically 2 minus 3x over here, right? Because this is minus x. And wait, I have some like this is minus x. Something like this will be minus 3x. And this is minus x. This is minus 3x. And this part, this y is basically 2, right? This function is y equals 2 minus 3x. Right? Ignore the dashes over here. These are all filled. There's no discontinuity of any sort. And so 2 minus 3x is less than 2 means this part, right? This part of the function, the real line. So basically, if x is greater than 0, you have all y's mapped to all x's greater than 0. At 0, you have -2, and greater than 0, you have from minus infinity to -2, but -2 is not included. So range is open minus infinity to open 2, right? This is not -2, this is +2, this +2, this +2. So you have minus infinity to 2. That's graph. Right? Graphing is easier then. Right? Your second part, which is x cube plus 2, where x is a real number, right? There you have x belongs to. So x, this is x squared plus 2, right? If x is real, then x squared is always greater than or equal to 0, right? First thing to note. This always holds true. So x squared plus 2 is always greater than or equal to 2, because it's basically addition of 2 on either side, right? So basically your range then becomes, right? This is 2 to infinity open, because nothing can be equal to infinity. Infinities are always open, right? So from this inequality that x squared plus 2 is greater than or equal to 2, you have the range as close to infinity, right? Graphing this function out, x square is a parabola, right? That touches 0, right? This is x squared. Excuse my stupid drawing. This is basically y equals x squared. Oh my god, it's just too much struggle. This is y equals x squared. And if this is 2, then a parabola that touches at 2 is basically 2 plus x squared, right? And so you can see that for all x line, you have a range of 2 to whatever is above 2. So that's basically close to infinity, right? That is your graph answer. And your last part, that is f of x is x, where x is a real number. I'm not going to draw it out because the drawing is going to be stupid. I'm just going to show you where it's on the book itself, right? Fx is x is our identity function, y equals fx equals x. You can see that the graph is like this. So it basically covers each and every member on the real line, and it maps to each and every member on the real line, right? For 0 is 0, for 2 is 2, for 4 is 4, for 6 is 6, for 8 is 8. And for -2 is -2, -4 is -4, -6 is -6, -6 -8, etc., etc. Catch the queen. It extends on either side of the real of 0, right? So here you have that, right? So here you have that fx is x, where x is a real number, means that x belongs to R, capital R, real line, and that fx is also, if fx, since it is exactly equal to x, right, also belongs to the real line R, right? And it has every member on the real line R. So basically, the range capital R is equal to the real line, right? That's your answer to part 3, right? Ranges are. Here the range is to infinity. For 1, the range is minus infinity to 2. And for 3, the range is a real line itself, the real number line itself. Right? That finishes question number 5. That finishes exercise 2.3. And then you have miscellaneous exercises on which there are 12 questions. Okay, 12 more times I have to suffer, or the stupid pen, which does not write properly, right? F is this function, G is this function. So if it's a function, G is not a function, right? For something to be a function or something to not be a function, you need to check the condition again, right? And the condition is that for every, for everything defined in the domain, there is only one, and there is one and only one image, right? Here you see that the only place where anything can be repeated, right, where any image can be repeated, is at this exact point 3, right? Because x is equal to 3 over here, x is equal to 3 over here, x is equal to 2 over here, x is also equal to 2 over here. right? At any other point, you don't have any overlaps, and so there can only be only one image existing, right? So it does not make any sense to compare those points at all because they do not affect your answer in any way. It's going to be more efficient to just compare the critical points, that is 3 and 2, right? So f of 3 minus, right? I'm going to compare the first, the first part, that is 0 to 3. So I'm going to write this as 3 minus, where I'm approaching 3 from the negative side, from the less than side, right? I'm approaching 3 from 2, basically, right? So this is basically 3 squared, right? Because from the negative side, if you approach 3, the function is x squared. So this is basically 3 squared, which is 9, right? And f of 3 plus, f of 3 plus is equal to the function 3x, that is 3 times 3, that is also 9. Since both are equal, you have the same image, which means that 3 does not have any, x equals 3 does not have any two different images, which means that f is a function, right? Because every other point has a unique image. So f is a function, right? Now for g of, why is g looking like g of 2 minus, right? Because first we are dealing with the less than side. G of 2 minus equals, it's x squared. So it's basically 2 squared, which is 4. But g of 2 plus equals 3 into 2, which is 6, right? 4 is not equal to 6. 4 is not equal to 6. So you have two different images for the same number 2. So basically, you have 2, 4 and 2, 6 belonging to the function f, right? Belonging to, oh, it's not f, it's g. I'm sorry. Belonging to g. So since each element has to have a unique image for it to be a function, but this does not have a unique image, but it has two images, g is not a function, right? Therefore, f is a function, g is not a function. This basically playing with the properties of functions, right? So there's no big need to worry because it's not related to that, right? F of x equals x square, find f of 1.1 minus f of 1 by 1.1 minus 1. I'm going to directly simplify this, say that the bottom is 0, right? 1.1 minus 1 is 0. And then here, I'm just going to substitute directly in the function and say that this is 1.1 squared minus 1 squared, right? This is basically 1.21 minus 1 whole into 10, because 0.1 is 1 by 10, comes up to give 10, right? So this is basically 0.21 into 10, which is 2.1, done, right? Nothing to think of. It's just brute force. Find the domain of the function, blah, right? First of all, if you're given a function like this, just think that the codomain, which is the domain, first think of the domain and the codomain to be the real numbers R, right? See whether the function exists for every value in R. If it does not, then just exclude whatever values exist where the function does not exist. Just exclude them from R in the domain. That's your final answer, right? So this is basically how you proceed for things for questions like question number 3, right? So question number 3 gives you x squared plus 2x plus 1. That's basically x plus 1 the whole squared. Petitioning for a new whiteboard. This x plus 1 the whole squared divided by this x squared minus 8x plus 12, that is basically x minus 2 into x minus 6, right? X minus 2 into x minus 6. You can do this, you can do the factorization by any way if you want. I'm just I've just seen this, seen these types of questions so many times that is second is for me to do the factorization. So this is basically your f, right? Your function f. Now you can see that for any division, if the denominator is 0, the function does not exist. It's infinity, and infinity does not exist on the real line. So your function's domain cannot hold the points 2 and 6. Right? Your function's domain cannot hold the points 2 and 6. So, but for every other point x on the real line R other than 2 and 6, you have some defined value of the function f. Right? So basically, finally, your domain is R excluding 2 and 6. Right? Or if you want to write it more, if you want to write it in a more continuous sense, you write that the domain D is equal to, right? It's minus infinity to 2. It's not equal to 2. So it's a closed bracket. Union, it's a 2 going to 6, right? Because everything in between 2 and 6 is also included, right? Union, it's 6 to infinity, right? That is the domain. Right? Or it's basically capital R minus set of 2 and 6. Both are the same. Both are the same representation. There's quite literally zero difference between these two. Right? That's question number 3 taken care of. Now going to question number 4. Right? Wow. Good questions. Find the remaining range of the real function defined by fx equals root of x minus 1. Right? Again, square root means that this whatever is under the root has to be greater than 0. So basically, for the domain x minus 1 is greater than or equal to 0. Wow. It's greater than or equal to 0. Right? So basically, x is greater than or equal to 1. X is greater than or equal to 1. So you have that the domain D equals the closed set of 1 to infinity. Right? That's your domain. Right? And then for the range, you have that y is basically the positive root of x minus 1. Right? And x minus 1 is basically greater than or equal to 0. So y is something, y is a root over something that is greater than or equal to 0. Right? So y basically belongs to 0 to, right? 0 is included. Because if x is 1, then this whole thing is, this thing is 0. So y is 0. Right? So y belongs to 0 to infinity. That is the range. Is the range smaller, capital R. Right? So your domain D is 1 comma infinity, 1 is included. And the range is 0 to infinity, 0 is included. Right? This is square bracket. 0 is included. That's your 4th question. Right? If you want to graph it out, you see that basically this is the positive half of the parabola y square equals x minus 1. So if this is x equals 1, then this is your function y equals root over x minus 1. Right? The positive half of the parabola defined by y square equals x. Right? You can see that the domain is basically 1 to infinity inclusive, while the range is while whatever it maps to y is basically 0 to infinity inclusive. Right? That. And then question number 5, in the same vein as before, fx is mod of x minus 1. I'm directly going to graph it out because doing it algebraically is just a waste of time right now. So this is basically mod of x minus 1, right? So if x is 1, then your whole thing becomes 0. So this and this, right? This is basically your function f. The domain D is basically all values of x where it's defined, which is the real line R itself, right? The real line R, and the range capital R is basically whatever it maps to on the y-axis, which is 0 to infinity, right? Which is 0 to infinity. That takes care of question number 5 also, right? We can also write this. We can write this. We can write this as R0, right? That's question number 5. Now going to question number 6. Halfway through, we are halfway through. Yeah. Now it's x comma x square by 1 plus x square. Determine the range of f. Right? Now the range of f is basically this part, right? The range is always determined by the second of each coordinate pair, and x belongs to R. So if you find the range of whatever this function is, x squared x squared by 1 plus x squared, then you determine the range of f also, right? Here, see, you have to notice that x square is always greater than or equal to 0, right? And 1 plus x square is always greater than x square, right? X square is greater than or equal to 0. 1 plus x square is always greater than x square. So x square by 1 plus x square is always less than 1. Right? It cannot be equal to 1, never. Right? Because 1 plus x square is always 1 greater than x square. So it is infinitesimally less than 1 if x tends to infinity, but it's not equal to 1. It's never equal to 1. Right? But x can be this can be 0 because if x square is 0 by 1, this is 0. Right? So basically, this function is lying between 0 and 1, where it can take the value of 0, but it cannot take the value of 1. Right? So the range R is equal to close 0 to open 1. That's your answer. Right? Now going to question number 7. Fg defined by this. Find f plus g, f minus g, and f by g. Right? So f plus g is basically adding these two functions, x and x adds, the constant adds, which means that f plus g, I'll write this as h1x, right? The first resultant h of x equals, this is 3x minus 2, right? Minus 3 plus 1 is minus 2, right? This is 1. You have 2, that is f minus g, which is again a subtraction of, the x terms and the constant terms separately. There's no mixing, right? h2 of x equals, this is x minus 2x, that is minus x. Wow. This is minus x minus 4. This is 1 minus 3, that is plus 4, right? So this is x plus 1 minus 2x plus 3, 2x minus 3, that is x minus 2x plus 1 plus 3, that is minus x plus 4. It's not minus 4, this is plus 4, right? That is h2 of x. And you have for the third thing, so h3 of x equaling f by g, that is x plus 1 divided by 2x minus 3 if gx is not 0, right? You should not forget the condition, because if gx is 0, then this does not become a function because the value does not exist, right? So gx should not be equal to 0. So x does not equal 3 by 2, right? That is your condition for the third thing. This is f by g, that is h3 of x, that's x plus 1 by 2x minus 3, where x is not equal to 3 by 2. Right? That is kind of the 7th question. And my hand is spinning. Question number 8. Question number 8. Let f equals 1, 1, 2, 3, 0, minus 1, minus 1, 3 be a function from z to z defined by ax plus b for some integers a and b. Determine a. Right? This kind of a function, this kind of a question, you can see that this is basically a linear, this basically a line, and you have 4 points that lie on the line, right? So, a line is defined by any 2 points. So for this kind of a question, just take the 2 points that make the question most simple, right? For example, this 0, minus 1 makes your life very easy, right? Because if x is 0, that means fx is basically b. And 1, 1 is also very easy to map to, because that means that 1 is basically equal to a plus b, right? So, choose things as that your life is more simple. I'm going to choose the 2 points 1, 1 and 0, minus 1 to find a and b, right? So here, first of all, for point 1, 1, right? Right in the equation fx equals x plus b, you have 1 equals a into 1 plus b, that is basically a plus b, right? That is your equation number 1. And your equation number 2 is for the point 0, minus 1, right? I'll take for 0, minus 1, where you have this to be 0. Oh, wait, no, this is minus 1 equals 0 plus b, right? Which means that b equals minus 1. First thing, right? And so from here, A equals 2. Because 2 minus 1 is what is equal to 1? Nothing else, right? So I found A and B, finish. That's the question, over, right? Go ahead. If you want to check, if you want to check your answer, right? F of x equals 2x minus 1. That's 2 into 2 minus 1, that's 3, right? Because that's 2 into 2 is 4, 4 minus 1 is 3. And here is minus 1 into 2, that's minus 2. Minus 2 minus 3, minus 1 is minus, right? There you go. You have checked your answer with the other 2 points. Your other 2 points lie on the line. Your line is correct, over, right? That. Question number 9. Let the relation from n to n be defined by this: a equals b squared, right? A equals b squared. Are the following true? A comma a belongs to R, right? You can see that if a belongs to R, that means that a equals a squared, right? Which means that a equals 0 or 1. That's it. You cannot have any other number for a, because if a is 2, then 2 is, then a squared is basically 4, which means that 2 equals 4, which is not possible, right? So 2 comma 4 is not a pair in A, it's not a pair in R. So a comma a belongs to R is basically false. 1 is false, right? That is 1. This property is known as a reflexive property, right? If a comma a belongs to R, right? If for some relation R, if this property holds true, right? If a belongs to R, then that relation is said to be reflexive, right? It's something that you'll learn in class 12, I think. But yeah, whatever. This is called the reflexive property, right? Second, if AB belongs to R, implying BA belongs to R, right? So again, take 2 and 4, right? 2 comma 4 belongs to R, which means that basically, wait, this is not 2 comma 4, this is 4 comma 4. One second. My bad. This is 4 comma 4. A equals B squared. So this is basically 4, right? Y. This is basically 4 comma 2. Right? 4 comma 2 is an R. But 2 comma 4 means that 2 equals 4 squared, right? Which is not possible because 2 is a square root 4, it's not 4 squared, right? So 2 comma 4 does not belong to R. So basically, your property number 2, that AB belongs to R implies BA belongs to R, is false. Again, 2 is false, right? Because you have this disproving your statement. 4 comma 2 belongs to R because 4 is 2 squared, but 2 is not 4 squared. So 2 comma 4 does not belong to R, right? Disproves your statement. This is a symmetric property of a relation. If this is true, then your relation is symmetric, right? And 3 is also false again, right? Easy to demonstrate because see, 4 2 belongs to R. Then you have 16 4 belonging to R because 4 squared is 16. But 16 comma 2 does not belong. Wait. This is AB. Wait, this is AB. This is BC. Then your 16 comma 2, right, which is your AC. This does not belong to R because 16 is 2 power 4. It's not 2 squared, right? This does not belong to R. So therefore, 3 is false. So you have all 3 being false. And this third property is called the transitive property, right? Because AB, BC transits to AC, right? This is transitive. This is called the transitive property. So you have the reflexive property, you have the symmetric property, you have the transitive property, all being false for this relation, AB belonging to N and A equals B squared, right? So going proceeding to the third last question number 10, right? A is 1, 2, 3, 4, B is 1, 5, 9, 11, 15, 16, F is this, are the following two. F is a relation. Now you can see that F for each element in F, you have the first elements, everything belonging to A, right? 1, 2, 3, 4. It's 1, 2, 3, 4, 2. And all the second elements belong to B. 1, 5, 9, and 11. Right? 1, 5, 9, and 11. So F is a relation from A to B. 1 is true. 1 is true. 1 is basically true. Right? Artic does not necessarily make sense. So 1 is true. Right? 2, on the other hand, that F is a function from A to B. That is false. Why? Because you see that this 2,9, there is also 2,11, right? You have a less than relation, which is not possible for a function, right? So if this exists, it's not a function. So 2 is false, right? Second last question, question number 11. Question number 11. Let F be the subset of ZZ defined by F equals AB, comma A plus B, where A and B belong to Z. Is F a function, right? So you have that the domain is basically all numbers A, B, right? So take any two, sets of A and B, which give the same product, right? For example, 1, 6, 2, and 3, right? You don't even need to go to the negative. You don't even need to go to these two numbers. You can also take the negative numbers, but this proves a point, right? Take this is A, this is B, let's say. Right? If this is 1, 6, you get the pair. You get the pair 6, 7, right? Because it's AB, comma A plus B, right? This generates a pair 6, 7, but this generates a pair 6, 5, right? You have the same pre-image, but you don't have the same image. You have some kind of a less than relation, which is not possible for a function. So basically, this F is not a function, right? It's not a function from Z to Z, right? I mean, you can also do this using the negative numbers, because this generates plus 6, comma minus 7. This is again something having the same pre-image, but not the same image. So basically, you have a less than relation again, which means that your F is not a function, right? You can prove it in any way. That's not an issue, but you just need to get the idea that you have to have two different pairs of A and B having the same product AB, right? And a different sum A plus B, of course. Coming to the last question, 9, 10, 11, 12, 13. That's A. And F be a function from A to N, be defined by Fn equals the highest prime factor of N. Find the range of N. So this is basically the highest prime factor of N. So find the prime factors of each of the 5 numbers in it, right? So 9 maps to 3, because the factors of 9 are 1, 3, and 9 only. There are only 3 factors, and this is the highest prime factor, right? 9 maps to 3. 10 maps to 5, because the factors of 10 are 1, 2, 5, 10, right? 11 maps to 11, right? Because 11's factors are 1 and 11 only. There are no other factors, right? 9, 10, 11, 12, 13, right? Again, 13 maps to 13 because 13 is prime. There are only 1 and 13 as factors, right? And 12 maps to 3 because factors of 12 are 1, 2, 3, 4, 6, wow, 6 and 12, right? You only have these factors, and 3 is the highest prime number, 11, 5, 13, right? So you have these numbers being mapped, right? In the set of natural numbers, this is A, and this is the set of natural numbers N, right? I'm not listing everything out. I'm just writing down whatever has been mapped to. But there's a set capital N, N of natural numbers, right? So your range is basically whatever you map each element to, right? So your range is basically the set of 3, 5, 11, and 13. That's it, right? Fine, guys, that finishes the whole chapter. Then you have a summary where you have the different definitions and blah, 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 whatever else comes in. So, right, one extra note here. If you guys find that some such A maps to something that's out of N, which is not possible, but if this N was not natural numbers, but let's say a random set defined by some other random roster, then you can directly write that this the F has a range that's outside N, right? Which means that you should not write that, right? You should not write that F has a range outside N. So you can't just state that and then go ahead with your own merry way. Basically, if that happens, then you have to write that F is not a function, but the range is basically what is given inside the capital N, right? So if let's say this was not capital N, but this was some random set N, which is 1 till 11, right? But not anything more than that. You have 13 mapping to 13, right? So your final range is going to be R dash equals 3, 5, and 11 only, right? You won't include 13 because 13 is not in the codomain. But you'll have an element in the domain which does not map to anything. That's something that you will notice when you continue your range studies. But this is a tricky question. This question has to be answered this way, and you can't just write that it's not a function, or you can just write that the range is outside or whatever is given in the what is given in the codomain. So you can't just say that and go ahead, right? You have to write the range which is inside the codomain only, right? Having said that, I think I'll stop here. I don't think there is anything. So yeah, thank you guys. Hope you found this interesting.